Have you ever wondered what keeps the gas planets to their shapes? An intriguing question, isn't it? When we gaze into the cosmos, we notice these majestic celestial bodies. They're not solid like our Earth, but rather they're composed of gas. We call them gas giants, or more specifically, Jupiter, Saturn, Uranus, and Neptune. These planets, unlike the rocky ones in our solar system, don't have a definite surface. Their shapes seem to defy logic, don't they? How can something as transient and ever-changing as gas maintain such a consistent form? It's a fascinating question that has piqued the curiosity of many a stargazer and scientist alike. The answer, it turns out, isn't as mystical as it may seem. It's not a tale of cosmic magic, but rather one of physics and natural laws. So, what's the secret? Well, the answer lies in the unique physical properties of these celestial bodies. Let's delve into this cosmic mystery together. The shapes of gas planets, or gas giants as they are often called, are determined by a combination of factors. Picture a spinning top. Just like how the top's rotation keeps it upright, a gas giant's rotation helps maintain its shape. The faster it spins, the more it tends to flatten at the poles and bulge at the equator. This is due to centrifugal force, which pushes matter away from the spin axis. Now imagine a rock being pulled towards the ground by an invisible force. That's gravity at work. Similarly, the immense gravity of gas giants pulls everything towards the planet's core, trying to shape the planet into a perfect sphere. Lastly, consider the nature of gases. They're not rigid like solids, they're flexible and compressible, meaning they can change shape easily. This flexibility allows gas giants to achieve their unique shapes. So it's a delicate balance of rotation, gravity, and the properties of gases that gives these planets their distinct shapes. Gravity plays a crucial role in shaping the gas planets. But what is gravity, really? In its simplest form, gravity is a force of attraction that pulls any two objects toward each other, with the strength of this pull directly related to the mass of the objects and the distance between them. Now, imagine a planet. It's a massive object floating in space, and every part of this planet is pulling on every other part. The result? An inward tug that pulls everything toward the center. This is why planets, including gas giants, take on a spherical shape. It's like a cosmic game of tug-of-war, with every atom pulling on every other atom, and the collective result is a shape that minimizes the distance to the center. This spherical shape is the ultimate balancing act between the inward pull of gravity and the outward push of pressure from the gas. Gravity, therefore, works as a celestial sculptor, molding the planets into spheres. Rotation, too, has a significant impact on the shape of the gas giants. Now, let's delve into the intricacies of this fascinating phenomenon. Picture a spinning top. As it twirls, it tends to bulge outwards at its equator, right? Well, the same principle applies to our gas giants. As these planets rotate, they experience a centrifugal force, an outward push that's strongest at the equator. This force is what causes the planets to expand at the equator and appear squashed at the poles, resulting in an oblate shape. Jupiter, for instance, is a perfect example of this, with its diameter at the equator being slightly larger than the diameter at the poles. So, the next time you gaze up at the night sky and marvel at these celestial bodies, remember that their unique oblate shapes are not random. They're a direct result of their rotation. In essence, the spinning of the planets on their axes sculpts their unique oblate shapes.